by the battery. Another problem. A 3 microfarad capacitor and a 6 microfarad capacitor are connected in series, and the combination is connected in parallel with an 8 microfarad capacitor. What is the equivalent capacitance of the combination? Now, we did this on that animation just now we used. Can you draw a diagram of this? A 3 microfarad capacitor and a 6 microfarad capacitor are in series, and the combination is connected in parallel with an 8 microfarad capacitor. Well, look at this. A 3 microfarad and a 6 microfarad are in series, and then this combination is connected across these 2 points. So is the 8 microfarad. That's the meaning of a parallel connection. So this combination and the 8 microfarad are connected across the same 2 points. So this represents that connection. Can you now find the total capacitance? Now, where do you begin? You got to begin with this. What is the total capacitance? We can actually do it in mind. It is not a difficult problem at all. What is the total capacitance of 3 microfarad and 6 microfarad in series? If you keep track of the equation that I've been giving you, when 2 capacitances are connected in series, the total capacitance C equal to C1 C2 divided by C1 plus C2. So the total capacitance of this combination will be 3 times 6 divided by 3 plus 6. What is that? 3 times 6 is 18. 3 plus 6 is 9. 18 divided by 9 is 2. So a 3 microfarad and a 6 microfarad in series gives you a total capacitance of 2 microfarad. So this is equivalent to a 2 microfarad. What you now have is a 2 microfarad in parallel with an 8 microfarad. The total capacitance will be 2 plus 8, that is 10. You see, it's a mental problem. Let's write it down. C1 is 3 microfarad, C2 is 6 microfarad, and C3 is 8 microfarad. 3 microfarad and 6 microfarad in series gives an equivalent capacitance given by C equal to C1 C2 over C1 plus C2. We did that. That will be 2 microfarad. And now the arrangement is now the same as a 2 microfarad capacitor. This is now equal to 2 microfarad. So you can see I have said this is equal to, I replaced this combination by a 2 microfarad, and that is connected in parallel to an 8 microfarad. So this diagram is exactly the same as this diagram. The total capacitance C equal to 2 plus 8, that is 10 microfarad. You must learn how to produce these kind of simple circuits and calculate the total capacitance. Alright, another one. If the potential difference between points A and B is 200 volts, find A, the total equivalent capacitance between A and B, the charge stored in each capacitor, and the total energy stored. The total stored energy. Well, what we have is a 4 microfarad and a 15 microfarad are in series, and that combination is connected to a 12 microfarad in parallel, and that whole combination is connected across a 200 volt supply. That is what we have. Okay. First of all, we look at this. We need to find the equivalent capacitance of this. A 4 microfarad and a 15 microfarad in series gives you an equivalent capacitance given by, can you tell me, given by what? Given by C1 C2 over C1 plus C2. 4 times 15 divided by 4 plus 15. That will be 4 times 15 divided by 4 plus 15. That is 3.16 microfarad. So this can now be replaced by a single capacitor of 3.16 microfarad. There you are. You can see I just removed it, and I'm going to now put there a 3.16 microfarad. This is now our circuit. Now we have a 3.16 microfarad and a 12 microfarad are in parallel. What is the total capacitance there? It will be 12 plus 3.16, that will be 15.16 microfarad. So this 3.16 microfarad is connected parallel to 12 microfarad, gives us an equivalent capacitance, a total capacitance C equal to C1 plus C2. That will be 15.16 microfarad. So the total capacitance in the circuit is 15.16. The total potential is 200 volt. Have we done the part A? Yes, we have done part A. The total equivalent capacitance between points A and B is 15.16 microfarad. B, the charge stored in each capacitor. What is the charge stored in each capacitor? Well, the total charge Q, we know the total capacitance. The total capacitance is 15.16 microfarad, and the total potential is 200 volt, and therefore using those two values you can find the total charge that is taken from the power supply. Q equal to CV, that will be 15.16 microfarad times 200 volt. Now look at this, I have not converted the microfarad to farad. Why? If I leave the capacitance in microfarad, the amount of charge calculated will be in microcoulomb. So I get here, this will be 3032 microcoulomb. So be careful about the use of the unit. The total charge is 3032 microcoulomb. Now if you notice that 3032 microcoulomb, when it comes to this junction, it will divide into Q1 through this series circuit and Q2 through the 12 microfarad, so that Q1 plus Q2 will be this much. Alright. 3.16 microfarad and 12 microfarad are in parallel. Remember, this is 3.16. So this 3.16 and 12 microfarad are in parallel, so they have the same potential difference across each of them. Can you understand that? When capacitors are in parallel, their potential difference across each is the same, which is equal to the total potential. So this is our 3.16 and this is 12. They are in parallel. That means the potential difference across the 3.16 microfarad equal to 200 volts, and the potential difference across the 12 volt also equal to 200 volt. So the charge on the 12 microfarad capacitor is, you know the capacitance of the 12 microfarad, you know the potential across the 12 microfarad, which is equal to 200 volts. Therefore, the charge on the 12 microfarad will be Q equal to CV, which is 12 microfarad times 200 volt, and that is 2400 microcoulomb. Because I do a lot of copying and pasting, and that is how this comes. This is charge, it must be microcoulomb but not microfarad. So you must do these simple corrections that need to be done. The charge on the 12 microfarad is 12 microfarad times 200 volts, Q equal to CV. That is 2400 microcoulomb. Now look at this. When a total charge of 3032 microcoulomb comes to this point, 2400 goes into 12 microfarad. That means the remaining charge will be through these two capacitors, and because they are in series, each will have the same charge in it. So tell me, what is the charge on each of these? It will simply be 3032 minus 2400. Well, let's do that. Now, the remaining charge is shared between 4 microfarad and 15 microfarad. You see, the total charge Q equal to 3032, and the charge on the 12 microfarad is 2400. Therefore, when 3032 microfarad comes to this point, that 2400 goes this way. That means the remaining must come this way in the series circuit. And since they are in series, each has the same charge. And therefore, charge on each of them will be 3032 microcoulomb minus 2400 microcoulomb. That is 632 microcoulomb. Each of this has 632 microcoulomb across it. Okay, see, what is the total stored energy? Well, the total energy stored in the arrangement will be E equal to 1/2 CV squared. Do we know the total capacitance? Yes, we know the total capacitance. We just calculated in part A. And do we know the total voltage? Yes, the total voltage is 200 volt. Therefore, the total energy stored in the circuit will be 1/2 C. The total capacitance we calculated as 15.16 microfarad. Convert that to farad times 200 volts squared. That will be 0.303 joules. Always remember to use the correct unit. Now this is where most of you can go wrong.